A company has a fleet of trucks that are all 2 years old that will work acceptably for another 3 years. They originally cost $70,000 each, are currently worth $20,000 each, and will be worth $5,000 each when they are scrapped in 3 years' time. Their annual operating cost is $4,000 each. They have received a bid from a dealer to replace this fleet of trucks with new trucks that have the same capacity but lower operating costs, that will work acceptably for 5 years. These trucks will cost $80,000 new, be worth $60,000 in 2 years' time, and will be scrapped for $6,000 each in 5 years' time. Their annual operating cost will be $3,000. Should the company replace its fleet of trucks now? In this question, we're going to look at a company that has a fleet of trucks that are currently 2 years old. They've received a bid from a dealer to replace the trucks with new trucks that will last for another 5 years. The present trucks have got another 3 years of life remaining in them. The reason they might accept this deal is because the new trucks have got a lower cost per year as operating cost than the old trucks. However, they obviously have to pay more money for them because they're newer trucks. The question is, should they do this? So what we need to do is we need to work out the cost of each of these two different types of trucks per year for the rest of their life. So what we're going to do is we're going to call this one the Defender, and this one is the Challenger. So let's start off by looking at the old truck and at what is the annual equivalent value, the annual equivalent cost for running this truck per year. Well, first of all, we have to start with the capital cost. Now, for a Defender, the capital cost is the money that we could get if we sold it. So it cost $70,000 2 years ago, but we don't care about that. That's a sunk cost. That's money that's been spent and it's gone. There's nothing we can do. There's nothing that money changes. It doesn't change our profit because we've already spent it. So what we're interested in is what money could we get it for now? Well, we could get $50,000 for it now. So we're going to put that as our capital cost. So we're going to have minus $50,000. And we need to work out the annual equivalent of this amount. So we're going to multiply this by I, which in this case is 0.1, being 10%. We're going to also multiply that by 1.1, which is 1 plus I. We've got a remaining life of 3 years, so to the power of 3, divided by 1.1 to the power of 3 minus 1. Okay, that's our annual equivalent cost for the capital part. We also have to worry about the salvage value. Now, in 3 years' time, these vehicles will be 5 years old. So therefore, their salvage value will be 5 years. And this is money we get, so we add this on. So it's plus 5,000 times 0.1 divided by 1.1 to the power of 3 minus 1. And the other thing we have to worry about is the operating cost. And they are costing $4,000 per year. So we calculate these numbers and we get this term gives us minus 20,106 plus this term gives us 1,511 minus the $4,000 of the operating cost, which gives us a total of minus 22,595. Then we need to work out the value for the Challenger, which is the new truck. So our annual equivalent for our new truck, we're going to use the same formulas, but we have different numbers. This time we're buying the truck, so we need to pay $80,000 for the truck. So this will be minus 80,000 times 0.1 times 1.1, but this time it's going to last for 5 years. So we need to use to the power of 5 divided by 1.1 to the power of 5 minus 1. Then we need to work out our salvage value. Once again, it's going to be positive. We're going to get more money for this truck because it's a better truck. So it's going to be $6,000 times 0.1. And once again, this is in 5 years' time. So we're going to get 1.1 to the power of 5 minus 1 minus, and we've got our operating costs of $3,000. So this will give us minus 21,103 plus 983 minus 3,000. And when we add all of these up, we end up with minus 23,120. Now we're going to compare paying $22,595 per year with paying $23,120 per year. Which one would you prefer? I'd prefer to pay less money. So therefore, we'll keep the old trucks. Now, the most common question I have from students here is, why did we put this $50,000 up here instead of down here? A lot of students look at this and they think, well, if we buy the new truck, we have to pay this money and then we get this money. And they do the analysis with nothing here, but this term subtracted here. The reason this doesn't work is because these numbers here are different. If we took this and just said, okay, this is going to be 30,000, being 80 minus 50, and then we've got this power of 5 thing, we're going to get a different answer to what we get when we take it to the power of 3. And this can be a big problem. In fact, I can quite easily, and I have on Moodle, set up an example for you where doing it the wrong way and making minor changes to something that's completely irrelevant will give us the wrong answer. So it's very important that you do it this way, that you use the $50,000 is the market value becomes the capital cost. I know you don't pay that, but it's an opportunity cost. It's the cost of money that you're missing out on because you decide to keep the trucks. On the other hand, down here, we don't have anything to do with selling the trucks because that's a completely different time. So we down here, we just have the cost of the new trucks. And then we have all of the old truck costs kept together, all of the new truck costs kept together. We'll get our correct answers, and so we'll finally be able to make the correct decision.